Alright, start of this video. This is number 4-4. We're starting chapter 4. And I wanted to walk you through how to do this one. And I'll pause and ask you questions from time to time. So we've got on this problem, this is Sam collected data by measuring pencils of her classmates. She recorded the length of the painted part of each pencil. So here's the length of the painted part. And its weight. So weight is that way in grams. And that's that. So the painted part of the pencil, I'm assuming is if you have a pencil, right, like there's the eraser and there's the pencil and then it goes like that. This part is usually, the painted part. Eraser here. Anyway, that's my pencil. So, part A. Describe the association between weight and length of the pencil. Remember, describe the form, direction, strength, and outliers. So what we can see in this case, very generally speaking, is as the length of the pencil increases, so as we go this way on the graph, as the length of the paint of the pencil, increases, also you can see that the weight is going up. So if we were to imagine like kind of a line approximately of this thing, it would kind of look like that. And that thing, as the paint increases, so does the weight. I'm going to erase that for right now. But what the problem is actually looking for in the form, direction, strength, and outliers. An outlier is a piece of data that doesn't match the rest. So what we've got for what this one is looking for is the association that it's a strong, that's the strength, right? It's a strong positive because it's going up. Positive, and it's linear because we make a straight line. It's a positive linear association. All right, and there is one outlier at 2.3 let's say centimeters, right? Because it's centimeters. So this one right here is the outlier. Doesn't match the rest. Okay? All right, moving on to part B. Make a conjecture, which is a guess about why Sam's data had an outlier. So that's a tough one. Why is this one, do you think, totally wrong? And you can come up with all sorts of ideas, but I think what the textbook was looking for on this one is that Sam reversed the coordinates. So the coordinates 4.5, comma 2.3 would be better. That would be 4.5 would be around 2.3 would be about right there, and that would actually match the data. So Sam reversed the coordinates. All right, part C. Sam created a line of best fit, and in this case, you are given the line of best fit, which is W equals 1.4 plus 0.25 L, where L is the weight of the pencil in grams, and L is the length of the paint in centimeters. So what does the slope represent in this context? In this case, this part, the 0.25, is the slope. And that is, what does that represent? So an increase of 1 centimeter length is expected to increase the weight by 0.25 grams. So for every 1 centimeter length weight, you can picture this as being over 1, is increased by 1 gram. All right, and now we're going to use that in part D. So I'm going to scroll up here a little bit, and I'm looking at part D. Part D says Sam's teacher has a pencil with 11.5 centimeters of paint. Predict the weight of his teacher's pencil. So 11.5, if we were to think about a line on this thing approximately like that, 11.5 is about right there. My pencil was off by a little bit. So it's like right around 4 grams, a little less than 4 grams, right? Or we can use exactly this equation, right? When I put a 4 in there, oops, sorry, an 11.5, and I put this through a calculator, 1.4 plus 0.25 times, how much is this thing, 11.5? Put all that thing into the calculator, I'm going to get 4.3 grams, and according to my graph, I was off by a little bit. All right, part E, interpret the meaning of the y-intercepting concept in context. This is the y-intercept, right? Like if we were to draw this line, mine's off again by a little bit, but 1.4. So the y-intercept, when you interpret that, which is kind of hard, it basically means that you predict when the pencil's so short that there's no paint left, it's still going to weigh 1.4 grams. So when the pencil has no paint, it still weighs 1.4 grams. Alright, I'm going to now try to pause this thing.